Hello and welcome to Learning with Lovo. This is part 4 of my helicopter deep dive. This and the next video will focus on flight techniques. Obviously you can fly however you want in DCS, but these can be considered best practices and a more realistic way of operating. Let's first take a quick look at our instruments. There's a few we will be making a lot of use of. Torque. Either a round or vertical gauge, it expresses the amount of torque going through the drivetrain with danger zones illustrated. Temperature. You may have a few temp gauges, but the exhaust temp is basically the temp from inside the engine. It'll likely have warning and danger areas. Operating in the danger area for more than a short period of time can break the engine. RPM. These represent the RPMs of the engine and main rotor. Sometimes one gauge will have both, sometimes you'll have two gauges. If in flight you see the needles split on the combo gauge, your engine is broken. Vertical speed. This gauge shows your rate of ascent or descent. A needle at the 9 o'clock position shows level flight, rising up and clockwise for ascent and low and anti-clockwise for descent. To avoid VRS, don't descend faster than 500 feet per minute while slower than 40 knots. Flight techniques. Takeoff. So you're on the ground and you don't want to be anymore. You need to take off and depart. This involves either hovering and transitioning to forward flight, also known as a two-stage takeoff, or performing a rolling takeoff. There's a few ways to do this, so let's start with the basics. These should always be performed into wind. Hovering. Hovering refers to holding a stationary position in the air, and it's one of the unique things a helicopter can do. You'll want to perform a two-stage takeoff wherever possible, as it gives you time to evaluate the aircraft's available power and other issues before committing to significant airspeed or altitude. The collective controls the overall pitch and therefore thrust from the rotor disc. This will raise or lower you, as well as creating more or less torque, which will cause you to yaw. You must compensate for this with yaw pedals. Check your surroundings. You don't want a sudden accidental yaw motion to leave you without a tail rotor. You're going to be constantly visually checking a few different areas to ensure you're safe and aren't drifting off anywhere. This is called the hover scan. Out, scan the horizon to check your vertical movement and heading. Down, check your altitude and drift by looking 45 degrees to one side and 5 meters out through the chin bubble. In, check rotor RPM, torque and temps. Repeat this ad nauseum. Ensure you're properly started up and pull more collective smoothly while applying the power pedal to oppose the torque. You'll start to lose friction with the ground, and if you haven't got the yaw pedal or cyclic correct, it'll become apparent, letting you correct better. Stop applying collective here if the aircraft feels like it wants to pitch or roll. You can oppose this with the cyclic. The wind will be creating a flatback which you will have to oppose. If there is low or no wind, the tail rotor's sideways push will be needed to be compensated for with a cyclic input the same direction you see the rotor spin in front of you when starting up. This is the left side with an anti-clockwise spinning rotor like the Huey, BO105 and Kiowa, and a right side with a clockwise spinning rotor like the MI8 and Gazelle. You'll take off slightly low on that side. Pull collective again to add more thrust and repeat the process. Check your inputs balance you. If not, lower collective and correct. If they do, continue scanning and using the controls to maintain your position and heading. Turn into wind if it's safe to do so. Ascend to about 5 feet or 1.5 meters and trim out your cyclic pressure. You're now hovering. This may take a bit of practice as each control input often needs another input at the same time, like a collective change needing yaw pedal. Corrections should be made small and early. Dynamic rollover. You want to be cautious, as there's a point where a roll on the ground becomes inescapable. If you're rolling and moving with a skid or wheel on the ground, it can catch or drag and cause you to roll over. If this starts to occur, lower the collective to remove torque, because reverse cyclic might not save you. Transition. This could be from hover to forward flight or from forward flight to hover. We'll focus on hover to forward flight for now. In this case, we're going to move the cyclic forward and therefore tilt the disc forward. This will take some of our lift and turn it into thrust. We'll maintain height with the cyclic and counter that torque with the pedals, but you shouldn't need much. Continue scanning in front of you to maintain heading and inside to check temps and torques. As we accelerate, we'll outrun our ground cushion, but we will also outrun our induced flow and get trans lift. At some point, you'll likely have to use forward cyclic to counter the flatback. The trans lift will, if you don't reduce collective, start you on an ascent. You have now transitioned. Assume your helo's best climb speed, apply some collective and use aft stick to maintain that speed. You will now be climbing away. Rolling takeoff or a max performance takeoff. If you don't have the available power for a full hover, you can try a rolling takeoff. Make sure you have a suitable upwind area to roll over. When you're ready, begin your hover scan and pull into a very low hover. This shouldn't take your max power. If it does, you may not be able to even do a rolling takeoff. Start to taxi forward with forward stick and collective, maintaining your heading with pedal input. Expect the aircraft to try and settle. Use the remaining power to prevent this. As you accelerate, you will get translift. Use forward stick to prevent a steep climb. Avoid any heavy maneuvers until you have enough excess power to compensate for the loss in lifting thrust. No hover takeoff. Used when hovering would kick up enough snow or dust to blind you. Check your helo is set up and has no warnings, then establish a hover scan. When you're ready, smoothly pull up on the collective until you've reached max safe power. You'll quickly lift off the ground, so balance the torque with pedal and carefully apply forward stick to quickly get translift. The forward stick should be enough to prevent a significant climb, but not so much to descend nose down into the ground. Accelerate away and carry on as normal. Air taxi. You may have to get to a runway or other takeoff area before departing. You can air taxi to do this at a height of about 5 feet. This is if you don't have wheels. Achieve a hover as described earlier. Use a little cyclic to move in the direction you want, usually nose on, but if there's a strong wind, you should keep nose on to that instead. Use pedals to maintain desired heading, collective for height and cyclic for speed. Don't let your speed run away with you. Flight. That's enough about getting off the ground. Let's go over how you handle a helo in forward flight. Steady flight. Each helo has a different ideal cruise speed. Check the manual of your module to see what it suggests. Generally speaking, a torque of around 75% is a safe place to be. Set this with the collective and use forward stick to maintain a vertical speed of 0. Now we'll talk about balanced flight. This means pointing the way you're flying. You'll be used to maintaining heading with pedals, but at speed it'll be less clear if you're using the ride to mount, which will be a lot less than you needed in the hover. Additionally, you may have a crosswind giving you sideways velocity. Here we can turn to our turn and slip gauge. This is a combo gauge with a needle that lets us know how much we're banking, and a floating ball that moves to the outside of any sidewards movement. We're looking for steady flight here, so the turn gauge should be straight up. If we have any side slip, the ball will move to the opposite side, so step on the ball. This means if the ball is the left of center, apply left pedal. Wait a few seconds for it to settle and refine if necessary. Some helos have a string on the canopy. These give you wind direction for the hover and let you know the slip in the opposite way to the slip gauge. If the string is on the left, apply right pedal. Outside the hover, you should be maintaining balanced flight whenever you can. Climbing. Going up. You'll be doing a lot of it. Your aircraft will have an ideal climb speed. Let's say 70 knots for this example. Reach 70 knots. Usually this means slowing as you're at a faster cruise speed. Pull collective to establish a climb and power pedal to counter the torque and maintain balanced flight. At about 50 feet below your desired altitude, lower the nose to the same attitude you were in your cruise. Lower collective to stop climbing at your desired altitude. For a less efficient climb, you can perform a climb at cruise speed. Keep the same speed and attitude and pull more collective. Watch your gauges for overtemps or torques. 50 feet prior, lower collective to reach your desired altitude. Descending, going down, there's no way around it. Maintain attitude and lower collective. 700 to 1000 feet per minute is a safe rate in forward flight. Maintain balanced flight throughout. About 50 feet prior, increase collective to arrest your descent. Turning. Turns in forward flight are similar to in a plane. You use sidewards collective to bank the aircraft. Much like in fixed wing, you now have moved your lift vector away from gravity. This results in a descent. We use collective to compensate for this, as nosing up would cause us to slow down. This means if you're using your max available power in straight flight, you can't turn without slowing or descending. Power changes. This is a speed change in level flight. To change speed without changing height, we balance a reduction in collective with an aft cyclic. The aft stick will cause us to slow and climb, so we reduce collective enough to counteract this and maintain balanced flight throughout. To accelerate, we do the opposite. Forward stick, which will result in an acceleration and descent, balanced with pulling collective to maintain height. That's it for this episode. We're almost there with this helicopter deep dive. Next episode, we will be covering the various methods of approach and landing. Thanks for watching Learning with Lovo.